Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This presentation introduces the Raspberry Pi 5 single-board microcomputer that was announced in September 2023. It has taken some time for the ships to cross the pond for single quantity supplies to retail customers. Well, better late than never. Made in Wales, the Raspberry Pi 5 is. Listening to Welsh choir sing "The Old Land of My Fathers" at his soccer match elevates one's emotions higher than joining into singing "You Will Never Walk Alone," in my personal opinion. Of course, your opinion is always respected. But here is the Raspberry Pi 5. Same basic footprint, with much faster but a few simple long-desired features like a power switch, real-time clock, and SSD support. So let us look at the key features of this product. But before we begin, let us give the product a spin. The Raspberry Pi family consists of single-board microcomputers that originated from the minds of its founders to develop a learning tool for educators, hobbyists, and developers. The versatility and low entry-level price of the first Raspberry Pi led to rapid acceptance for commercial and industrial use. And of course, there is the sentiment, imitation is the sincerest form of flattery. The Raspberry Pi Foundation has had difficult but enviable decisions to support learning and industry concurrently, leading to acute shortages of products in recent years for retail consumers and much to the delight of eBay sellers. The pandemic-induced supply chain constraints added to severe challenges in the available to promise dates. Raspberry Pi 5 took 7 years from concept to production. The central processing unit uses the quad ARM Cortex A76 system on a chip with 7 nanometer substrate for general processing tasks. It decodes, issues, and executes more instructions than earlier generations naturally. It has an overall 35% performance boost over its predecessor, 40% better power efficiency, 4 times improvement in machine learning benchmarks. The key areas examined in the subsequent slides are graphical processing unit, networking, ports, and power. BCM 2712 is a new 16 nanometer application processor from Broadcom with numerous architectural enhancements. It has a quad-core 64-bit ARM Cortex A76 processor clocked at 2.4 GHz with 512 kilobytes per core L2 caches and a 2 megabyte shared L3 cache. Overclocking has been documented by Shenzhen companies already. The combination of a new core, a higher clock speed, and a smaller process geometry yields a much faster Raspberry Pi and one that consumes much less power for a given workload. To keep the system supplied with memory through its high bandwidth, there is a 32-bit LPDDR4X SDRAM subsystem running at 4.2 billion transfers per second. That is almost double the throughput of the predecessor Raspberry Pi 4 computer. The primary storage device is still the micro SD card, but now there is an optional PCIe interface for SSD cards. A prototype has been demonstrated, but there is no word on the formal launch date for the official hat to connect an SSD. Undoubtedly, the Shenzhen companies are burning midnight oil to provide alternate solutions through the industry standard PCIe interface. The Video Core 7 GPU is a new graphics processor that was released by Broadcom in 2023. Its key features are up to 50% faster graphics performance than the Video Core 6. Supports OpenGL ES 3.1 and Vulkan 1.2. Has quad-core GPU with a clock speed of 800 MHz, 16 pipelines. Supports up to 8 GB of LPDDR4 RAM. Dedicated hardware, video decoder and encoder. Dual 4K P60 HDMI display output. This is a major upgrade from the Raspberry Pi 4, which had a single 4K P60 HDMI output. The dual HDMI outputs allow you to connect two 4K displays at once. The Infineon CYW 43455 combo chip is at the heart of Wi-Fi support. For wireless connectivity, the Raspberry Pi 5 features dual band 802.11ac Wi-Fi, supporting both the 2.4 GHz and the 5 GHz frequency bands. This allows for faster and more reliable wireless connections compared to previous Raspberry Pi models. The 5 GHz band offers less interference and higher bandwidth, ideal for streaming videos, playing online games, and transferring large files. The Raspberry Pi 5 comes equipped with Bluetooth 5.0 and Bluetooth Low Energy (BLE), enabling wireless communication with a wide range of peripherals such as Bluetooth headphones, speakers, and keyboards. BLE is particularly useful for connecting devices that require low power consumption, such as fitness trackers and smart sensors. The Raspberry Pi 5 boasts a built-in gigabit Ethernet port, providing a wired network connection with speeds up to 1 gigabit per second. This ensures fast and reliable data transfer for tasks like downloading large files, streaming multimedia content, and connecting to network-based devices. With the new PoE Plus hat, hardware attached on top, the Raspberry Pi 5 can receive power over the Ethernet cable, eliminating the need for a dedicated power adapter. This is particularly useful for installations where power outlets are scarce or difficult to reach. Two versions of this hat will be released in 2024. The Raspberry Pi 5 introduces a PCIe 2.0 interface, allowing for the expansion of networking capabilities through the addition of compatible PCIe adapters. This enhances flexibility and opens up possibilities for special network applications. This connector permits the use of M.2 SSD for vastly expanded storage and fast boot. There will be two hats for this purpose, one for use directly with larger M.2 SSD boards and the other with the new PoE Plus hat for smaller footprints M.2 SSD boards. The Raspberry Pi 5 computer uses the in-house designed RP1 controller chip for external connectivity. The USB 3 ports have more total bandwidth at faster speeds. The camera and display connectors are interchangeable to permit one of each or two of the same. And now UART debug has been formalized with a jumper port that can connect to yet another Raspberry Pi product, the debug board. There is an onboard PC-style power button to support hard and soft power off and power on events. Briefly pressing the power button will display a window soliciting further input for shutdown, reboot, or logout. Pressing the power button briefly again will start the shutdown process. There is a slight variation during headless mode operation since responding to the window prompt is impractical in this mode. In this headless mode, pressing the power button will initiate a shutdown, but the board will remain powered and the computer can be restarted by pressing the power button again. In this mode, holding down the power button for a few seconds longer will initiate a hard shutdown. For those undaunted by soldering on the board, there is an option to connect one's own power button. It is advisable to use a power supply to the board rated at 5.1 volts DC and 5 amps. There is a new power supply adapter rated at 27 watts to meet this advisory. The power connection port is USB-C. Caution is urged when using current industry phone charger USB cables for the power connector interface because these cables are not rated above 15 watts. Furthermore, if your plans include the use of additional storage, such as SSD, through the PCIe interface, please do not ignore the power supply recommendations for the Raspberry Pi 5. The VCGen CMD command permits the examination of configuration information and status. There are many command options, but some of the more popular ones read data from the video core for use in applications or for monitoring the health of the computer. The VCGen CMD command can be used in a shell script to monitor status. Here is an example of one such script to keep an eye on the temperatures of the CPU and the GPU. The shell script example generates an output that is logged for trend analysis as well as display. Let's go ahead and log in to the RPi 5 remotely using SSH in a passwordless connection. And you can see we've logged in remotely. It's the RPi 5 and it's running Bookworm 64-bit operating system. So we'll try out some VCGen commands now, but before we do that, let's look at the list of all the commands that are available. So we type in VCGen CMD commands and you get a list of some of the commands. You don't get all the parameters for the commands, but essentially some of them don't require any parameters, so you can just go ahead and type VCGen CMD space measure temperature, for example, or measure volts, and it'll give you the corresponding value. So let's look at the temperature reading right now, and we'll type in VCGen CMD space measure underbar temp. The temperature is read back as 57.1 degrees Celsius. Note the readings are always in Celsius, and if you want it in Fahrenheit, you'll have to do your own conversion. It's a message out to the console that can be redirected to any log file, and you can process it any which way you can. We have measure volts also similarly, and we can get other values, configuration settings. You can specify USB throughput, and these are some of the examples that we have in here shown for you. Hope this is useful, and try to use it in your scripts and then log the values. I have Nagios, which is a remote monitoring system that monitors the temperature for all Raspberry Pi computers in the farm, and perhaps in some other video tutorial I'll get to show that to you. You can let Nagios monitor the temperature of the Raspberry Pi computers in your farm. Log in to your Raspberry Pi computer and take a look at the Nagios libexec folder. So we can go see lib. And there's a whole bunch of utilities, the sh. And you can see that it reports the temperatures, and it has settings for warning. If it reaches 58.2, it's a warning. If it reaches 60, it's serious, and 70 is critical. You better start taking serious action. The utility itself is very simple, but there is no need for us to get into the details except to recognize that the vc-gen-cmd command is used. And so now we can go ahead and look at how that result is reported. So let's take a look at the data for the Raspberry Pi 5 computer. As you know, the host name is Raspberry Pi 35, and I have it up here, so I'll just go and click on it. And here are all the sessions. The one that we're looking for is current temperature, and you can see it's telling us the values that it's monitoring. The status is okay, and it gives us a whole bunch of other information. But the important point that I wanted to make here is that you can log this and analyze the trend over time. So just a quick introduction, but hopefully later on we'll explore it more in depth. The Mobile Industry Processor Interface, MIPI, created the Camera Serial Interface, CSI, and the Display Serial Interface, DSI. Raspberry Pi 5 combines these ports to support dual-purpose CSI and DSI MIPI ports. Two displays or two cameras or one of each can now be supported using flat flexible cables, FFC, which are available in three lengths, 200, 300, and 500 millimeters from the foundation. Display devices presently require a setting change in the boot configuration file corresponding to the display device. Please check with the display device manufacturer's instructions for this interface. The High Efficiency Video Coding, HEVC, supports 4K resolution to stream higher quality video at manageable bit rates. HEVC takes an intelligent approach to encoding video to avoid sending duplicate information. This feature lowers the size of the file being transmitted, leading to higher bandwidth and data quality. VideoCore 7 is Broadcom's solution for low-power mobile multimedia processors. It is a highly optimized 7th generation chip that can run complete applications. Coupling VideoCore chip with the main Cortex CPU, the Raspberry Pi 5 heralds a new platform for scientific calculations and integrated display. The performance improvement is almost 4 times better than previous Raspberry Pi model. Vulkan is a new programming interface for hardware accelerated graphics. It is meant for lower level use than OpenGL, which has stood the test of time for decades. Long live OpenGL, since it will continue to sustain scientific applications. Developers seeking better performance on single board microcomputers will gravitate towards Vulkan to reduce CPU overhead. The Raspberry Pi 5 image processing is a hybrid operation with tasks partially performed for image signal processing on the Raspberry Pi Foundation developed RP1 chip and the Broadcom BCM2712 chip. The image signal processor, ISP, converts raw camera images into full color images. The raw camera image format, called Bayer pattern, can be 8, 10, or 12 bits. The primary RGB colors are in preset patterns such as BGGR, GBGR, RGBG, etc. These formats are not suited well to the human eye. The conversion to a normal RGB or YUV format is performed by the image signal processor. The key steps in converting the signal from the camera image sensor to a file for use in simple applications include some of the following steps. Receive the Bayer pattern data from the image sensor. Perform demosaicing to estimate missing color information. Missing color information is estimated and inserted using well-documented algorithms. Convert the demosaic image to a standard color space, for example, RGB or YUV. Apply gain and gamma correction for brightness and contrast. Perform white balance correction to remove color casts caused by different lighting conditions. This is a very simplified view of the processing steps. Some other processes, such as sharpening, noise reduction, and color correction, are optional. Finally, there is an onboard power button. This feature is probably the most requested one in the history of Raspberry Pi computers. When you plug your Raspberry Pi 5 into power for the first time, it will automatically turn on and boot into the operating system without having to push the button. If you are running the Raspberry Pi desktop, you can initiate a clean shutdown by briefly pressing the power button located on the left-hand side of the board and then releasing it. This will cause a desktop menu to appear asking whether you want to shut down, reboot, or log out. You can select whether you want to shut down or reboot, or alternatively pressing the power button briefly for a second time, you will initiate a clean shutdown. You can have your own custom switching for power to the board. The J2 jumper, located between the real-time clock RTC battery connector and the board edge is a breakout, allowing you to add your own power button to the Raspberry Pi 5 board by adding a normally open, no momentary switch bridging the two pads. Briefly closing this switch will perform the same actions as the onboard power button. There is an official heat sink with a fan for the Raspberry Pi 5 computer. It is official in the sense that it is designed and manufactured by Raspberry Pi Foundation. It is called an active heatsink. There is an accompanying case too from the Foundation to retain the Raspberry Pi 5 board with the active heatsink. Unfortunately, it too is not in stock at my friendly retailers, both online as well as bricks and mortars store. This case will have another variation when the Power over Ethernet hat for the Raspberry Pi 5 is released. Furthermore, nothing has been disclosed by the Foundation regarding the planned hat or the PCIe connector. The Raspberry Pi 5 requires more power than previous models. The output rating of the official power supply is 5.1 volts DC at 5 amps. The cable is 17 American wire gauge or AWG. Consumer USB-C cables are thinner and cannot convey the required power. If you plan to attach accessories to the board, please heed this requirement. Raspberry Pi operating system has three major variations: Raspberry Pi OS with desktop, Raspberry Pi OS with desktop and recommended software, Raspberry Pi OS Lite. All three variations are available in 32-bit and 64-bit versions. Since Raspberry Pi 5 requires the Bookworm release of the operating system, it is unnecessary to discuss the legacy versions of the Raspberry Pi operating systems in this video. Bookworm is the common name for the Debian Release 12 operating system. Debian 12 can be installed too. Ubuntu operating system in several flavors is another option too. You may find it expedient to use the official imaging application, the RPi Imager, to prepare the micro SD card for the first boot. Of course, you can override the OS suggested by this app by selecting an alternate image. The Ubuntu operating system for Raspberry Pi has three primary flavors: desktop, server, and core. There is a third-party operating system for embedded systems called amperes. Finally, for customized ARM devices, there is a RISC operating system, RISC OS Pi, that can be evaluated. There are many other specific purpose operating systems for the Raspberry Pi. There are home assistants and home automation, Antheus for digital signage, Kali Linux for security penetration tests, 3D printers, Full Page OS displays a full-page browser on boot in kiosk mode. Moodlebox is an open-source distribution combining a wireless access point with a full-featured Moodle server. Falcon Player is an appliance used for managing and controlling animated light shows. Darkboard is a customizable display for photos, calendars, news, weather, and so much more. Given the fact that the Raspberry Pi 5 computer is nearly twice as fast as its predecessor model, renewed attention on full-fledged integrated development environment (IDE) is desirable. Make no mistake, desktop computers have not stood still, and the complexity in IDE functionality is ever increasing. Nevertheless, it is worthwhile for learning or educational purposes to explore some IDEs that one would use as a professional developer. There are many IDEs that come to mind. I am choosing two that begin to make sense for daily use during the Raspberry Pi 5 computer. The first one, pronounced cute, but named with only two letters only, is a multi-platform language solution that has a slight learning curve if one has not used CMake previously. The second one, PyCharm, primarily oriented for Python, is truly a productivity enabler. It will help you write better code more quickly, guaranteed. The following demonstrations cannot teach anything about Qt or PyCharm. These demonstrations are simply intended to push you to evaluate these applications after you have finished viewing this video. And of course, the big if is that you have access to a Raspberry Pi 5. Despite all the noble statements by the Raspberry Pi Foundation, the Raspberry Pi 5 is still not available in retail stores across the pond and other parts of the world except the United Kingdom. Before we get started on exploring the IDE, let's take a look at the Raspberry Pi 5 computer that we're going to use for that purpose. The computer does not have a monitor, so it's going to operate in what we call headless mode, and for that reason I'm using virtual network here through Tiger VNC. And to give you an idea what we have here, I'm going to just go to the console and look at the configuration. It's Raspberry Pi 5. It must run the Bookworm, which is Debian 12 operating system. I've chosen the 64-bit. And you can see it's 8 gigs. And the processor runs at a whopping 2.4 gigahertz. Unheard of in the Raspberry Pi world. One other thing that I'd like to point out while we're here is that we're using the Wayfire window manager rather than the traditional X11. So these are a couple of things that you need to keep in mind as we work our way through the exercise of how to use an IDE in Raspberry Pi so that you are productive. So let's take a look at a few more essential items for configuration when you want to use remote desktop for Raspberry Pi 5 as it stands today. Real VNC is no longer supported, so you will have to use something else like Tiger VNC for this purpose. Unfortunately, in doing so, there are some challenges, and we have to go and recognize that it is very difficult to stay abreast of all the changes that take place by all the different software configurations that you have. So the first thing is to go to Advanced Options, select, and take a look at whether you want to use Wayland or X11. If you are using old versions of hardware, Raspberry 4 and older, then you may want to avoid Wayland and just stick to X11. On the other hand, if you're using Raspberry Pi 5, then you should use Wayfire because you have no choice other than to use Debian 12 Bookworm, and Real VNC is not supported for Wayland. There are two considerations when licensing Qt for learning purposes on Raspberry Pi platforms, for designers and for developers. Both licenses are free for 12 months upon application. Renewal is routine if terms and conditions are applicable. There is no technical support, but there is an active community forum where newbies can get questions and inquiries answered in a positive manner. The Qt editor permits coding in several languages such as C++, Python, JavaScript, and more, with context-sensitive syntax highlighting, code completion, and documentation. Version integrates with most popular packages such as Git, Subversion, Mercurial, and more. Project management, together with full CMake support, makes development very productive. Code can run on desktop, mobile, and embedded operating systems using build settings to switch between targets. Test and debug applications without deploying to physical devices. CMake will have to be installed separately prior to the start of this exercise. The simplest application is a console application. The default settings enable the guided steps, also called the wizard, to create the essential files with the following information: minimum CMake version, project name, version and programming language, rules for calling Qt tools, compiler information, name of the executable, reference to libraries if any, and files to install. Build and run the application. Once again, this example is simply to identify that a very powerful IDE is now practical on the Raspberry Pi platform. Step-by-step narration of even a Hello World exercise using Qt Creator is beyond the scope of the current video. Let's build a simple C++ Hello World console application using Qt. So we launch Qt Creator and select Create Project. We want to use Qt console application, and we can choose the folder where we want it to reside. So we'll go ahead and drill down, and conveniently we have a folder for that purpose, and we'll call the application hello. Obviously we're going to use CMake for our build system. We click on next. We're not going to worry about languages and translation, so we click on next, and then we let the kit selection be default for now to keep it simple, and we're not going to add it to version control, so we click on finish. You can see the source file is created. There are a couple of simple things that I'd like to add to make it easier for us to just run this quickly. So we'll do an include q debug, and then we'll put the traditional hello world message out there so that you can see that it has run, right? So q debug hello world, and then we have to do a qtendl, right? So that's all we have to do. We go to build, and we can just say rebuild, build a project, since it was the first time. We look at the status bar for the build and wait for it to disappear, which will indicate that it's completed. It's done, and now we can go ahead and run it. So we just come here and run it, and you can see immediately it gives us the message hello world. This is a very, very simple example just to show you that it is indeed practical. It may not be the best platform for doing C++ development, but now with Raspberry Pi 5, you can use Qt to help you build more efficient and fancier programs. The key features of the PyCharm Community Edition are the versatile editor, graphical debugger and test runner, refactoring, and version control system support. If you are used to using a virtual environment for your Python development work, you will find PyCharm extremely practical. After dismissing the welcome screen, one can proceed to customize preferences and settings. Ideally, first-time users should spend some time learning the features using the interactive courses offered within the IDE. Then create a new project, or open an existing one, or better still, retrieve one from a version control system such as GitHub. It will take dozens of videos simply to introduce the basic features of PyCharm. It does not make sense to even attempt to do so in this video. The key takeaway is that using the Raspberry Pi 5 computer for meaningful development work with an advanced tool like PyCharm makes more sense than ever before. Let's take a quick look at the second IDE, PyCharm, running on Raspberry Pi 5. So we go ahead and launch PyCharm, and it takes a little longer than Qt, but nevertheless it will come up, and you will see that it has a very nice IDE, just like other IDEs that you may be familiar with, and the project is on the left side. I will not go through the exercise of creating a new project. I just want to show you an existing file, and here's a sample Python code, and it's just a variation on the hello world exercise. To run it, I just click on this button, and then it ran and it finished because I did not pass any parameters for the name. And to do that, we can go back and edit the configuration. And we can say here, wherever we're running, this is the working directory, this is the script that it's running. So we can go ahead and change all these and run it again. So we can choose which Python script we want to launch when we hit the run button. Click on the folder icon and let's go back and choose main py. Once we're done, we can click on OK and leave it at that. Or if we want to run, we can run it again by clicking on this button. And you can see it ran and it printed the message, howdy dude, because dude was the parameter that was being passed. Again, a very, very simple example just to show you that the IDE works and the time lapse is not that bad. So I hope that you get a chance to try some of these advanced IDEs using the Raspberry Pi when you can get your hold on the hardware. This video was a quick introduction to the Raspberry Pi 5 computer. The key features were reviewed. Some of the planned official accessories were mentioned. And then to demonstrate that the Raspberry Pi 5 has significant performance improvements over its predecessor model, two professional integrated development environments, IDE, were demonstrated very superficially. That's all, folks. Please provide feedback in any which way you can. And also, stay tuned for more tutorials in this series. This presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally or inadvertently omitted anyone or any resource. A very big thank you to y'all. Come back to the channel soon.